chapter 16 today, and then we'll have the test for 16 next week. Any questions on this? Which one? Cobalt plus the 6 ammonia. How to do that one? Okay. Right, quickly we'll go through it. Okay.
All right, cobalt 3 plus 6 NH3 yields the hexamine cobalt complex. Plus, what was K for this one?
Let me look up the K value here. 4.5 times 10 to the 33.
All right, so you do the ice table, right? This was 0.100 molar. Was it 3.00 molar? And I assume nothing's reacted yet. 0 molar there. And so what do you want to do next? Reset. Do you see there's an imbalance here? Because when you look at the K value, it's enormous, 10 to the 33. It tells you all the atoms should be on the right side. So we should reset this one. And so we reset, and that means this is going to be minus Y molar, minus 6Y molar, and plus Y molar. And so resetting will generate, well, what's the limiting reagent here? Is it the cobalt or the ammonia? The cobalt. And so we're going to lose all that, which tells me that Y must be 0.100. And so 6 times 0.100 will be 0.600. And so 3 minus 0.600 will give me 2.40. I'm losing 0.6 from there. This is going to be 2.40. This is going to be 0.100 molar. And it just makes sense to reset this automatically because of this. I mean, this would be a very unusual looking well water. And so this is just going to be the concentration of the complex. You know, if I use the square brackets for the complex, then I'd do this, you know, double square brackets to show the concentration. Divided by the concentration of cobalt 3 plus times the concentration of NH3 raised to the 6th power here. So this is actually a 7th order equation. The unfortunately in algebra, you know, maybe not this class. I forgot to mention this to the morning class, but you know, some people say, why are we spending so much time talking about algebra? I wish we didn't have to spend any time talking about algebra, to be honest, because I'd much rather not talk about the algebra to solve this. But unfortunately, the algebra that's a prereq for this class is not enough. You cannot solve these equations just using the prereq algebra. And so we have to use the little tricks. So, you know, in math, you don't usually like to do these tricks because you're supposed to solve it, you know, as is. So we got to figure out what we're going to put in here. I'm not finished. I jumped ahead. And so we know what direction this goes in. This is going to be plus x molar, plus 6x molar, minus x molar. And so the equilibrium, I got x molar, 2.40, plus 6x molar, and then 0.100 minus x molar. Did you ever do resetting in algebra? Probably never did that, right? But you know, if you don't reset this problem, can you solve it? It's impossible to solve this problem without resetting it. And so if you don't reset this, you wouldn't have gotten an answer. Nobody. And this would be x times 2.40 plus 6x to the 6th. And the nice thing about resetting is once we reset all the atoms to the right side, the change should be very small. If the change is very small, then our other trick will work. What's the other trick we use is a simplifying assumption, which is 0.100 minus x. Every semester, though, I get people who just don't want to do any of these because they think it's not proper math. But the situation is when as you go on in science, the problems get more and more horrendous, more and more difficult. And if you don't use little things like these or approximation methods or whatever else, you can't solve it. And I think I mentioned the Schrodinger equation. You know, the Schrodinger equation, if you've had differential equations, which is like if you had the last semester of calculus, linear algebra and differential equations, then the Schrodinger equation is easy to solve for the hydrogen atom. But if you go on to helium, you can't solve it. If you try to solve the Schrodinger equation for the helium atom, you're done. That's it. No answer, right? And so you have to use all kinds of little tricks. Well, the tricks get a heck of a lot more sophisticated as you go on. You know, they're not these simple tricks like this, but there are other much more sophisticated approximation methods that they use mathematically to come up with some kind of reasonable answer. Otherwise, they just don't get anywhere. Well, anyway, continuing on with this, we go x. This is just a point, you know, because every semester students come and talk to me about, you know, this kind of trickery is not proper. And you shouldn't have to do it. You know, we didn't do it in math. Yes, you didn't do it in math. I wish you did. 2.40 to the 6th. And so now it's a lot easier to solve for x. So I'll let you finish solving this one for x. And does the simplifying assumption work? It works great in this particular case. The percent change is very small, and so simplifying assumption is justified. And I shouldn't say you need these tricks because you could always do what? Successive approximations, you know. And so if you did not reset this, then actually you could have solved it using, did anybody solve it using successive approximations without resetting? Well, anyway, we could, now the algebra is now very easy, you know. Here, we could just, 2.4 to the 6th power, we get 2.4 to the 6th power. It's 191.1 x. And so this is going to equal 0.100 minus x over 191.1. It's more space than I'm allowed, but I'll just carry one extra x. And then multiply it by 4.5 times 10 to the 33 times 4.5 times 10 to the 33. I got 8.599 times 10 to the 35th x is equal to 0.100 minus x. So let's add one x to this and then divide by that. And so plus 1, and then invert it in times 0.1. Invert times 0.1. 1.16 times 10 to the negative 37. 1.162. Let's go extra digit here. So let's check, are we justified? Well, the percent change is going to equal our initial 2.4 times 6x. So it'd be 6x over the initial, which is 2.40 times 100%. And so the change is times that by 6. So times 6 divided by 2.4 times 100. The percent change comes out to 2.90 times 10 to the negative 35%, which is just nothing for the percent change. So the percent change is good. Everything looks good. And so let's just go ahead and plug those numbers in over here. We're going to get 1.162 times 10 to the negative 30, what was it, 37? 10 to the negative 37. Now 2.4 minus 10 to the negative 37 molar, even if it's 6 times that, is, so this is going to be 2.40, plus 6x. So what is, plus 6 times that. What is 6 times 1.162? Let's just do it. 6 times 1.162 times 10 to the negative 37. 6.972 times 10 to the negative 37. And so I need 36 zeros. 1, 2. Well, why don't you guys finish this here and double check the answer to see if it works out.
trying to do a trick. It was just like, it's all bad. That's what was good about this we were gonna ask you what, these were right before the text. Two questions. No, it was not. ATM. I'm gonna ask you how you felt about it on Thursday.
So you might ask on the commission. Where's that?
Yeah, it was almost the whole multiple choice. Those two were. That's why I said this. I felt like at the test where I could thought I did good. I get slow in the test. No, no, I just. No. Yeah, right? Like, what the hell? I feel like everything just wanted to come out. No, like, yeah. Yep. Shit, dude. I have this, this thing on Twitter, right? With my buddies. Telling her to you want to see it? Kind of like therapy and stuff.
I've taken him so many times, I know what he was expecting, so.
Really?
So I took anatomy to fire
Yes. I saw that on the front page, right? You did. My friend sent me this link and I was like reading it, right? Oh my god, it's so funny.
For some reason.
Something was like, it was like, dude, I do it. Like every single hour, dude, I got check out this one class. And I was like, oh. And then like, this other dude was like, yeah.
He said it was.
Remember he said his
It's
video
kind of like far.
whatever the one you put on the test.
People don't
He said
find
it
it like
is
pleasant, but then
Yeah.
you still do it because they will feel uncomfortable if you don't.
Yeah, he said it really cool.
I guess that's true, but like, stuff like.
Just the kind of thing.
Yeah. So,
Yeah. And then I was just using my, I don't know what I started doing that.
Did you do the certinaldehyde one instead? Is it like really similar?
Oh, where did I try? No, I don't even remember. I think I just, someone did the pH, they really, I just did the one,
Yeah.
yeah, the very part of the I don't know, where I just.
I'm talking like it's
Mhm.
Did it ever,
office, the office is right there. But
It doesn't take that long to like go
maybe
there.
he's thinking it's not.
No, it's not like, and the first time I was like, oh, he's doing the thing again. The second time I was like, oh, he's done again. And he goes up from like the right hand, right? And then like the second goes to the left hand, he's just like peeking and he's like this. So creepy.
He was peeking?
Yeah.
What is he, here too?
Yeah, I think so. I think he's like testing us or something. If we cheat or something, but like, it was really creepy. I was just minding my own business and trying to look up. And that was just like, freaking. And then like after the I love checking in my store, I was there for like a minute.
I mean, I wouldn't.
Yeah, I wouldn't
But
either.
first of all, why are you leaving the class?
Yeah, exactly. Like, I was like, oh, fuck, we should I know. I know.
So what you did the first time, the first time, I was like.
I know. I was like, yo, what the fuck?
You know, that
I felt unsafe.
Me too, I was like,
Seriously.
People just trying to like set us up.
I know, right?
Like, like it's so shady.
there's, that one is not
All right, sorry.
that there's.
So, what did you get for these? What does this come out to? This number come out to on your calculator? You punch it out on your calculator. Because actually this would be 36 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20, 21. And then a 1, 1, 6, 2. Can your calculator handle this calculation?
No.
What's your calculator going to do if you did that? It's just going to round it to 0.100.
Yeah.
Did it work? Did you double check your answer? It worked? Okay, then that was it. All right. Were there other questions? No, just that one? Okay. All right.
I have questions for chapter 24 homework.
Chapter, which one? 24?
24.
All right.
54, following concentration cell is constructed, and then I've never seen these. So Ag line, Ag plus, in parentheses, 0.1 molar, in parentheses, silver cyanide.
Silver cyanide?
Silver
Dicyanoargentate? This?
Yes. And then, 0.10 molar cyanide. Ion.
All right, this one is coming later.
Yeah.
This one, I must have screwed up the assignment. For right now, do you just have nomenclature? We haven't talked about
Okay.
these.
So anything that's above, beyond, like, just naming?
Yeah, right.
Okay.
Just skip those. All right, any other questions? Yeah, you can adjust your homework assignment that way, but this one's going to be out. Okay, we're going to continue with chapter 16. Actually, we're going to finish up chapter 16 today. Let's talk about, we did acid, we did monoprotic and diprotic acid. Let's look at bases next. And so for bases, I left this recording here. For the bases, we have a KB equation. A minus plus H2O liquid. This is going to produce HA plus OH minus. And so, KB is going to equal the base hydrolysis, which is going just to be, the HA concentration times the hydroxide ion concentration over the A- concentration. Let me stop this. We'll cut off